Hi friends, welcome to Civil Learning Library for the topic Tension Members Part 3. For Part 1 and Part 2, links provided in the description. In this Part 3, we will see the Eyebar design. An Eyebar is a special type of pin-connected member. The pinholes are located at ends and it is enlarged as shown in this figure. Commonly, this kind of Eyebar tension members are used for long span bridges and stresses in earlier time. We will assume some load and we will check this Eyebar tension member. We will assume dead load as 20 kN and live load as 50 kN, and yield strength of the material is 250 and ultimate is 400. And next, coming to geometry details of the Eyebar, we are assuming width of the Eyebar as 100 mm and B is 75 mm. Here this is the width and B is the edge of the hole to the edge of this Eyebar, and T is the thickness of the Eyebar. Then T head is this distance and D is pin diameter, and DH is this hole diameter, and R is this radius. Next is dimensional check for Eyebar. The first check is thickness of the Eyebar. It should be greater than 12.5 mm. So here our thickness is 16 mm, hence okay. Second check is width should be less than 80. So 8 into 16 we will get 128, and our width is 100, which is lesser than 80, hence okay. Third check is dia should be greater than, pin dia should be greater than 7 by 8 into W. So our dia is 90 mm, which is greater than 87.5, hence this is also okay. Fourth check is dia hole should be lesser than or equal to D plus 1 by 32. But here if you are giving, this will give lesser value, so we need at least 1 mm clearance. So we are keeping DH as 91 mm. And fifth one is this radius. It should be greater than DH plus 2B. So our DH value is 91 plus 2 into our B value is 75. If we are getting, we will get 241, and our R value is 245, which is greater than 241, and it's okay. Then last check is 2 by 3 W should be lesser than B, and this B should be lesser than or equal to 3 by 4 into width of the Eyebar. So 2 by 3 into width of the Eyebar 100, then we will get 66.6, which is lesser than our B value, and this B is lesser than or equal to 3 by 4 into W. So that also satisfied here, hence okay. If it is not satisfied, then we have to increase the width or this B distance. Then we will calculate the factored load. 1.2 into our dead load is 20 plus 1.6 into live load, it is 104 kilonewton. Then now we will check the yield strength of this Eyebar for this 104 kilonewton. Next, available tensile strength of the Eyebar. The formula is Fi into Ag. Fi is, we know that yield strength 250 into area of the Eyebar. So we know that width is 100 and thickness of the Eyebar is 16. So we will get the value of 400 kilonewton. And then we have to multiply this with the design factor of safety by T. Design factor of safety value is 0.9 for LRFD. So the capacity of the Eyebar is 360 kilonewton, which is greater than the record strength. Hence this Eyebar is okay. The Eyebar tension member available strength is always governed by the tensile yield limit state. Also, there is a special note given in AISC journal states that the Eyebar detailing limitations ensure that the tensile yielding limit state at the Eyebar body will control the strength of the Eyebar itself. So we have to meet this all that 6-dimensional criteria. Then only this final governing case will be the tensile yield limit state. Also, we have to check for the pin. The pin should also be checked for shear yielding, and the pin should be checked for bearing if the material strength is lower than that of the Eyebar. And for this example, the dimensions are provided approximately. So if we draw exactly, the dimension values will vary slightly. Thank you for watching the presentation. Hope this video is useful to you. Please like and subscribe to get more videos and notifications.